audio. Okay, recording. Yeah, it's recording now. Yeah, recording. All right. Come back here again. Let's see this. Well, I take the attendance first. Yeah. Number 8, we have Kashfi. Then we have Rosie, and then we have Sally. So absent. I didn't see Amin. Amin is not here. Amin not here. Asman is not here. Who else is not here? Amir. Yeah, Amir is not here. Fadli is also not here. And also, Fadli is here. Let me think. Bazli, Adila. There should be 11 of you. Sahibul is here, sir. It's not okay. So all these 4 is not here. All right. Have you tried the paper 5 I sent you yesterday?
Sudah, sir.
Ada sudah
Yes,
kasih
sir.
ya? All right. So what I'm gonna do today is we're gonna do a surf check lah. So let's have a look at the question paper. So this is the question paper here. Paper 5 2. This is the question paper. I need another set. Yeah. And the set here. The attendant will put over here lah, so I can see you here lah. Yeah. All right. So here we go. So you have some sort of a cylinder. Okay. So this is a cylinder. It's made from metal. So it's made from metal. Let me put the color I want first. Red, blue, red, and green lah. Okay. So let's blue. All right. So this is a metal cylinder. What you want to do is the student want to investigate the heating of a solid metal cylinder. So in the picture, you can see that there are area and also there are height, right? So let's see what does it want to do. The student placed the cylinder in the electrical heater of a beaker of water. The electrical heater switch on and the student measure the time T for the temperature of the water to increase by delta T. By the way, can you see this screen? Is it too small? Is it too small for you to see?
Okay, sir.
Okay, sir.
Okay.
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 Good.
Okay, sir.
All right. Thank you very much for the feedback. The number of a number of cylinders. So does mean here meaning that there is a what do you call that? There are banyak cylinder available of the same material. So these are the same material. Of different cross-sectional area are available. So it is suggested that the relationship is PTAH delta theta plus Z delta theta, and P is the power. So let me put another color here. So P is the power. This is the temperature change, yeah, and Z and W is the constant. So normally if it's a constant, we no need to describe how lah, yeah. So we no need to describe how to measure them, how to measure them, yeah. And then this is the most important part, yeah. What I want to show you here is the most important part. It's about the design. So this is the keyword here, the one I highlighted green here. This is the keyword here. So you want to find out the relationship between T and A, right? And then explain how you can use it to find the value of W and Z. So this is the task for today. Now, first step, okay, you no need to worry about how to draw the diagram, okay? So what I do is, you remember I always ask you to draw the table. You have to draw the uh, you need to draw the table in order to understand uh, which one is the variable and which one is the uh, dependent variable. So last time I teach you the table, I draw like this, right? I draw like in 3 column, right? I draw in 3 column. One is the independent, and then one is the. Now, what I want you to do is, you reverse the table. Instead of drawing like this, okay, instead of drawing like this, you draw it in the other way around. So that means this one will be your independent variable over the left side. So the title is on the left hand. The title is on the left hand side. Yeah, and then this one will be the something that you vary, and then this one is your dependent variable. Now, what I was trying to do today is, I want to show you that your answer can be displayed in some sort of a table, yeah, so that you no need to do it again and again. So I advise you to do like this in the exam. So now you have a table like this, okay, yeah. So you have another table, and then you have the constant. All right. So you have to go and check lah. Okay. So this one, you want to find the relationship between T and between what T and, let me go back here again. You want to find out the relationship between T and A. So T and A. So does mean this one is this T and A must be either the independent variable or the dependent variable. So as you know just now, you already read, there are a lot of different cylinder. So A will be your independent variable, and then the T will be the dependent variable where you need to measure. So that means all other than T and A, the rest here are all constant. Yeah. So we write down the constant here first. We have P. What again? We have P. We have H. We have W. What is W? Oh, sorry. W is the uh, constant. We have H. We have delta theta. Sorry, delta theta. Delta theta. So in this column here, right? You can write. You can cross it. Yeah. You can cross this column here. Use a ruler lah. You cross it like this, and then this side here, you write down how, oh sorry, how they are measured, yeah, how they are measured. So you can see now I make this answer space into some sort of a column. So this column will be able to help you to improve, yeah. So first A, we look at A. A is the area. So it's the area of the cylinder. So this is your cylinder with the area A, and then there's a length L. So you want to find out the area A, it will be area is equal to pi r square. But since we don't want to find out r, we can replace the r with a d. So it become a d square over 4. So how do we find this? Okay, you use what kind of instrument will allow us to find out the diameter. So hang on here. Amir, are you here, Amir?
Yes, sir.
Okay, Amir, can you tell me what will be the best instrument to find out the diameter, Amir?
Vernier caliper.
Okay, vernier caliper. Okay, we can use a vernier caliper. So use a vernier caliper.
So,
Yes.
kalau pakai micrometer dapat juga.
Wait, I write down first. Micrometer normally not advisable because of the range. Let me show you in the internet. You see the micrometer. Micrometer range. So if you look at the micrometer range, typical micrometer can only measure up to 25 mm only. Meaning that kalau kau lihat ni, dia punya gambar, this gap ni, I'm not sure you can see. Maximum the range only 25 . So not advisable lah. Okay. So cannot use micrometer. So I may just make the note there. Not advised. Micrometer not recommend for diameter because the range is only 2.5 cm . So we don't know how big is the cylinder. If it's more than 2.5, then it's useless. You cannot use the micrometer. Yeah. All right. Next one, we want to find out the T. Okay. Now who is here again? Asman But Asman, you're number 2 from the list. Asman, can you tell me how you find out the time?
Pakai digital stopwatch.
Okay, use digital stopwatch. Thank you. So, use digital stopwatch. All right. Danish, are you here, Danish?
Yes, sir.
Yes. Let's look at the soalan lagi sekali . What is the time you want to find out? Okay, as you can see from here, you can see the screen. So it's to measure the time for the temperature to increase by delta T. I think should be fine here. Let me just ask you another one Sorry. P. Yeah. P, Danish. Macam mana kau cari P, Danish? This one. You know what is P? P is power.
Power. Pakai tu sir. Apa ni? Formula P equal to IV. Lepas tu I-nya dari emitter. Voltnya dari power supply. Ada.
Voltnya from power supply.
Power supply.
Power supply. But the power supply tell you the volt kan? Did the power supply give you the voltage? You need a device,
Yang atas
right? Tapi you
mesti
still need a
device ke?
device. You need a device to give you the voltage some sort of a meter to give you the voltage. Because if you say power supply mana ada display kan? So what do you call this? Start with a V. Yeah.
Voltmeter.
Yes, it's the voltmeter. Alright, so correct, yeah. So this is the power of the what? Let me just show you again. Let me show you again. Power of what again? Let me see. Power of the heater. Power of the heater. So it's not about the cylinder. So this one is the power of heater. Okay. Okay. Thank you, Danish. So we have the next one, H. Let's see who is here again. After Danish, we have Fadli. Fadli, can you explain to me how you find out the height of the cylinder?
Meter rule.
Meter rule. Oh, this is salah lah tu sir punya this one. So this one should be height dah. Pakai meter rule lah. Okay. Thank you, Fadli. So height measure using meter rule. Alright. Next, we have a delta theta. Okay, delta theta. Let's see who is here next. I cannot see this person. Up AB. I think it's Basli. Yeah. Basli, are you there, Basli?
Yes, sir.
Yeah. Can you tell me, Basli, macam mana you find out the delta theta here, Basli?
Use thermometer.
Thermometer. Okay. Use thermometer to. Alright. They measure temperature. But this is a delta theta, Basli. So if this is a delta theta, what do you need to, what do you call that? What do you need to be add on to the detail lah? Pasal yang mau cari delta theta, a change in temperature. Okay, you use thermometer to measure the temperature, but how do you measure a change in temperature?
Macam mana, sir?
What is the purpose first? What do you do with the cylinder first? You eat it, you chew it, or you play around with it. What do you do with the cylinder? Yeah. What do you do with the cylinder? This one. What do you do with the cylinder is? Can you see that?
Atas apa ni, screen ku ni nampak lah.
You cannot see the screen.
Lagging sikit.
Oh. Kejap let me stop the sharing screen first We try again Yeah. So I stop the screen first. Stop sharing screen first. Where did I stop? This one. Yeah, broadcast stop. Okay. Sorry I restart again So this one now I stop the sharing screen. Okay, now I share again with audio. Start broadcast. Okay, I'm sharing screen now. I'm still recording. Yeah. So come back here. Oh, sorry. So Basli, can you see this? Cannot. Basli?
Ni nampak, sir.
You pakai
Ni nampak,
telefon?
sir. Oh.
Okay. Then never mind. I pass to another one. Who is the next one after you? Adila, is it? Yeah. Adila, are you there, Adila? Can you see the share screen? Adila? Okay, Adila is not here. Ian?
Yes, sir.
So, how do you measure how do you write down if I want to find out macam change in temperature?
We got initial temperature and the final temperature, and change in theta equal to final minus initial. Ensure that change in theta is constant for all experiments.
Okay. I get what you mean. Right? So, record initial and final temperature. So delta theta is final minus initial. Thank you. Basli, okay, Basli, can you hear what Ian say? All right.
Yes,
so
sir.
now we have all this description done. All right. We're gonna add on now with another column here. we will write down the analysis. Okay, analysis. But before we do the analysis, maybe we try to draw a picture of it lah. Okay, we try to draw a picture of it. So this one is your cylinder. You want to put the cylinder in water, right? If I'm not mistaken, hang on. You want to put it in water, if I'm not mistaken. Yeah, it mentioned here electrical heater in a beaker of water. So you want to put the cylinder in the water. So let's draw this. So this cylinder must be in the water of beaker. All right. So it has to have a heating. The heating coil is also, the heating is also inside. So maybe you can, sorry. Where is it? Sorry, the screen just wrong. Go away. Maybe you can make a heater here. Yeah. You call this the heater. So the heater got wire go outside, another wire go outside, and then you have the water inside here. So this one is the cylinder, something like this lah. Yeah, because you need to have the water inside. So this one is the beaker. So always try to put wire, put a label. So try to label everything that you draw. And then this one is connected to some sort of a power source. You must have a switch lah. You must have a switch in order to prevent it always turn on. Now, bear in mind, if you connect a power source, to a heater, normally we will have a resistor somewhere here, somewhere around here. So we might have a resistor here. The purpose of the resistor is to the purpose of the resistor here is to avoid overloading. Prevent overload the heater. Too many, the current flow is too high. It will cause problem afterward. And then just now, as you know, we want to find out the current, right? You can attach the ammeter here, yeah, and you want to calculate the. This is the power supply. Sorry, this is the power supply. So you can add a voltmeter here across the power supply, yeah. So you can find out the power equal to I times V, okay, I times V. So this is the power source. Right, so let's see what else we missed. We have a switch, resistor, everything is inside. Yeah. So let's go back to the picture. This is done. Analysis. So we have to come back to the analysis here again. Now, analysis. This is the formula that we want to find out. You have PT equal to AH W delta theta plus Z delta theta. So you want to make T and A some sort of Y equal to mx plus C. We call this the equation of straight line. Equation of straight line. Oh, sorry. So we make T the subject in this case lah. We make T the subject. So T equal to AH W delta theta over P plus Z delta theta over P, and then we make T equal to T is against A, so we take the A outside one of them, so the rest here will be H W delta theta over P. This one will be the gradient, okay, and then plus this one will be your y-intercept delta over P. So we rewrite here now, this will be y equal to mx plus c. So the gradient, this is your gradient. The y-intercept, this is the y-intercept. and then you can make your own statement lah. You can make a statement here. The gradient will be equal to HW delta theta over P. So your purpose is to find out the W. So you make W the subject. W will be equal to gradient time P over H delta theta. Next is your y-intercept. Your y-intercept is Z delta theta over P. So again, you want to make Z the subject, because that's you want to do here. Because you want to do here, you want to find W and Z the constant. So you have a y-intercept time P over delta theta. So this one will help you to find out the constant W and Z. Now, always remember under, yes,
If A against T boleh tak?
A against T. Boleh? Can. If you do A against T, that means the method will be the same. You will have another set of gradient different from mine, and y-intercept also different from mine. Can. Doable. Can. And last, you must comment. Yeah, you must comment
Okay.
valid or not. Yeah, thanks, Ian. Can. You must mention valid if is straight line. So always comment this one if a straight line. Now, does it pass through origin? As you can see, you have a y-intercept here. So that means it does not pass through origin. So straight line not passing through origin. Through origin. So this is one of the mark. I think I used all the paper already. I haven't reached the what do you call that? I haven't reached the safety precaution. So never mind. I use this slide here saja lah. Okay, safety. Okay. Safety precaution. Now I like to have somebody here after Ian. Inshira? Are you there, Inshira?
Yes.
So have you tried it already?
No.
Okay. So while we are
Tapi
doing now,
I'll try. Yeah.
bah,
I'll
can you?
try to answer.
Yeah, I like to ask you what will be the safety here.
Wear protective gloves, like safety gloves, so that you don't hurt your hands. Burn your hands.
Okay. Wear
Burn your
safety
hands.
to
And then wear protective goggles.
wear protective goggle. So goggle so same lah. Okay. Can you also give me another what do you call that? Another additional information that will help to improve our reading? Anything you can do here to improve the reading?
Take many readings
Take average data.
and find average.
So repeat. Maybe we just now, if you look at the variable, right? We have H. This one can be repeat. We have time. This one also can be repeat. And then we have the diameter also can be repeat. So yeah. So repeat measurement of it's not A, of D. Thank you, Inshira. Yeah. D, what else? The one I said, D, the H, and also the time. Or time cannot. Time is another story. Repeat the measurement of H at different position, because the length, the height of you can get different position, and take average. Alright. Now let's see anybody here. Inshira. After Inshira is this one cannot see the name. Let me check here. Dennis J. Yeah. Dennis J. Are you there, Dennis J?
Yes, sir.
Yeah. So can you tell me any other than these two can improve our reading? Can improve our experiment? Let me show you the picture. What can I do to improve the experiment? Get a better, accurate reading. Yeah.
So can I see yang bawah tadi? Yang the two.
You mean this one?
Hmm. Hmm. Supaya accurate lagi kan, sir?
Yeah. You want the reading correspond to the heating of the cylinder.
Heating.
Because you want to heat up the cylinder and then you calculate the temperature change, right? Jadi
Yeah.
you want to make sure that is as accurate as you can. Any idea?
Mesti check the temperature like throughout the experiment.
Or maybe another way lah. You take the same temperature chain. You get what I mean or not? For every
Yeah.
cylinder you use, the temperature chain must be the same. That means macam if you start at 40 degree, so every cylinder must also start at 40 degree lah. So constant temperature change lah. So maybe start at 40 degree and at, give me a number, Danish. How much
And
you want to go? You start at 40.
70.
Okay, 70 degrees Celsius. Yeah, something like that. So this one is very useful lah. So consistent. Jangan macam one cylinder you start from 40, the other cylinder you start from 60, the other one you start from 20. So it's not very consistent. All right, then we have another one here. Kashfi, yeah, Kashfi. Are you there, Kashfi?
Yes, sir.
Oh yeah, Kashfi is here. So Kashfi, anything else you want to add on to our additional information?
Aku
Anything?
terfikir lagi.
Alright. Another terfikir lagi. So never mind. We look at the last two again. Rosie and Sahibul. Yeah. Rosie, what do you think? Rosie, anything you want to add on?
Make sure the thermometer is at eye level.
Oh, meaning that prevent parallax error lah. So avoid parallax error when taking theta. Yeah. Si Sahibul?
Anu sir, boleh ke sir yang check for zero error?
Zero error because you use the boleh je, we try lah. Zero error check on vernier caliper, betul ah? Because we only use vernier caliper. Alright, this actually another one. Yeah, this actually another one here. Anybody from here lah who is available now lah? Yeah. Who is available now? Can you sorry, suggest this one? Yeah, anybody can suggest from here? Ada satu lagi. Yeah, there's actually one from here. Nobody
So is
yes.
it about the fly?
About the what?
Power supply.
Not really. Yeah.
Okay, I don't know.
Pasal silinder ke sir?
Yeah. Somewhere around here. What should you do here in order to improve?
Volume of water.
Insulate the beaker ke sir?
Maybe can. The volume of water must be constant volume. So every time you change cylinder, you make sure that the water inside must be constant. Maybe. See, Asman say something. Asman, what do you say just now?
Insulate the beaker ke sir?
You have to insulate so that no heat is lost. So maybe you can say here, you add some sort of insulation here. Yeah. So you make a insulate the beaker. Okay. And then the best thing is maybe you can add a lid. Yeah. You can add a lid here. Put a lid here so that to prevent the heat loss. So this will try to cut down the energy loss from the surrounding. Okay. All right. That is all, I think. Let's look at the mark scheme. Final one, before we cross our class today. Today we only managed to do one only. Don't want to do too many. So this is the mark scheme. Let's look at the mark scheme. Okay, here we are. Maybe I just minimize like that. Yeah. We measure just now, sudah kan? We measure just now. Where is our table here? Measure T. Okay, so this one we get 1 mark. This is done. And then make sure that the temperature change is constant. We did write down somewhere here. Yeah. So we write down somewhere here. So this one is done. We get another 1 mark. Okay. And then now we have a picture here. In your diagram, you must have a beaker, a cylinder, electric heater in the water. Oh, we missed something. We don't have a thermometer. Alamak. Okay, we missed a thermometer here. Fail. We missed a thermometer here. So that means you need to have a thermometer here attached. Maybe you need a retort stand somewhere here. Yeah. So we missed the thermometer. How can we miss the thermometer? So this one will get 0 mark. Yeah. Cause kira as a whole minimum level heater, thermometer, cylinder, water. This one we all done. This one can. We do all the hard work and then we cannot get the mark. Yeah, never mind. Diagram to show power heater. That means you have ammeter and voltmeter correctly. This one okay. This one can. We can get a 1 mark from here. Determine the time taken for the temperature using stopwatch. We mentioned that just now. Determine A by using we mentioned diameter, okay, and also we mentioned the formula for the area. We also mentioned T against A. Just now Ian will be terbalik. Ian is A against T, right? So it's also doable. That means your value will change also here. So we have done this first part here. We get 1, 2, 3, 4, 5, 6, 7, 8. We have 8 mark in the first page. All right. Then we have how many mark here in our additional information? Wear glove, heat proof, but it's a bracket. So if you don't write heat proof, it should be fine. You just wear brown to prevent burn. Keep P and H constant. We mentioned already. Keep initial temperature constant. This is what just now we discussed with Danish. This one done. Or with Amir just now. Volume of the water constant. Okay, so we have 1 mark here, 1 mark here, 1 mark here. Use caliper or ruler to measure height. We did that just now. Danish, Fadli say using ruler. You repeat measurement Who say repeat measurement just now? Inshira kali ya? Yeah. Inshira, you said repeat measurement ba? So this one, repeat measurement and then take average, 1 mark. Calculate power, this one Danish just now, you mentioned this one. Then repeat measurement for T and A, average. So this one also we got 1 mark here. Ensure heater are submerged. Oh, we didn't say this. Stir water, or we didn't say this, so we say 0. Relationship valid, not passing through origin, we mentioned that. Method to insulate the beaker, this is what Asman said just now, so it's another 1 mark here. So the total here is 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a 9 mark here. So altogether, we will score 17 out of 15, which is more than enough lah. Yeah. More than enough from this past year paper. All right, just before we finish today's class, I'd like to remind you, if you are not sure what to do in your question 1, I would advise you draw some sort of a table here in the answer space, because I remember I used to say draw a table somewhere, and then from the table you write down the information. That will take that will take time. Yeah. So to avoid time consumption, you make a table saja. You make a table in the answer space here. So the table will consist of this variable, independent variable, dependent variable, and constant. You write down them on the one side, and then you can also write down how you measure them. Yeah. And then you add on lah the analysis, and then you can also add on the safety and additional information, additional info. All right, so let's come back here again. Any other question from you? Let's start with Sahibul. Sahibul, ada soalan Sahibul?
Sir,
Nada? Okay, thank you.
ada sir.
Ada,
Ada sir.
yes.
Yang table tadi tu biarkan cuma tulis saja.
Yes. Biar macam mana. You can create your own table lah. You can make it nicely lah.
Okay.
Contohnya, where is it? Never mind. So maybe you can do macam ni kan tadi the independent variable and the constant. You can make a table macam ni, and then this is the answer, and then you can make a table here how it is measured macam ni. So you write down how they are measured. So this constant, there will be a lot of them. A lot of them. So you try to explain them lah. Then after that, the next line will be the analysis lah. So number 1 will be table. Number 2, the analysis. This one is 3 mark. Always remember. And the last one, you can write down the additional information. This one will be 6 mark, but sometimes we already say in the table already, so not a big problem lah. Rosie, any question, Rosie?
No, that's it.
Okay, thank you. We have who is this? Kashfi. Kashfi.
No, that's all clear.
All clear. Danish J. Oh,
Nada, sir.
Nada. Okay. Inshira.
Nada, sir.
Ian.
Nada, sir.
Adila. Oh, Adila, are you there? Nada. Maybe connection error. Basli.
Ada recording kan ni, sir?
Yes.
Okay.
Atau saja. Okay. Basli, can you see you still cannot see the screen?
Cannot, sir. Na dapat guna phone.
Maybe you try your laptop or whatever lah. See can or not lah. Fadli?
Sekarang
question?
tanya, Sir.
Yes. Nada?
Karang ja.
Karang saja. Okay. Danish?
Nada.
Asman?
Nada, sir.
Amir?
Values of W and Z saya punya apa sir?
Value of?
W and Z tadi.
This one. W and Z Ani.
Okay.
Alright.
Correct.
Yeah. So if there's no other question, we will end today's class. Thank you for your time and your participation. We'll see you again tomorrow. We will do paper 5 first because paper 5 is this Thursday. We focus on paper 5 first. Okay. Alright. If there's nothing you want to ask me, you can go now. If you have something to ask me, you can stay behind.
Thank you sir.
Alright.
Thank you, sir.
Thank you sir.
Thank you, sir.